they show a graph.
They don't show a graph, okay.
Draw your picture.
Are they telling us anything else about the length, the width? Are they saying anything else?
So it says, then divide it in half with a fence parallel to one side of the rectangle.
Yeah.
So that's all the information that's really given.
Okay, very good. Good. So let's start. So they want us to find the x and y so that we minimize the length. That part is not.
No, it says to minimize the cost of the fence.
The cost. Okay, so we want to minimize cost. And how much does it cost per linear foot, or does it say, or?
It doesn't say. Just what I told you is what it says. If you have everything up.
Okay. Okay. So the cost for the fence will be 3x multiplied by dollars per foot, which I don't know what it is yet. I'll look in a moment, and plus 2y times dollars per foot. We know that the area has to be 1.5 million, which means so x times y must equal 1.5 million. So from here, in order to create a function that is a function of one variable, I have to solve for one or the other. So let's say we solve for y. And we have to plug it in. But as long as we don't have a cost, so I'm trying to log in and see. Okay. Not sure why it's taking so long. But as long as I don't have the cost per foot, I have no idea how they want us to present the answer. So I have the cost, so this is C of x now. So it's 3x times, I don't know what that is.
Professor, I think they just want you to minimize the size of the fence to be the lowest cost, because the least fence will be the lowest cost.
So they don't want us to create the cost.
Yeah, I think it's just a question about how to make the fence as small as possible for this 1.5 million square feet.
But in that case, the cost, so we're not minimizing the cost then, so then we're minimizing the length. So then if we're not given the cost per, so this is, I finally got to it.
It's question 13, 4.7 on the exercises.
Okay. Yeah, I'm going to click on view. That's very interesting, because if we're minimizing the cost is one thing. If we're minimizing the length, it's a different story. So you said 13. Very good pick. Thank you. 12, 13. You said 14. I have totally different problems.
Are you on 4.7 exercises?
Yes, I'm going to share my screen right this moment. I hope I didn't lose my mind. But if I did, you're more than welcome to tell me. So it's 4.7 optimization problems. So I go to...
Yours looks so different.
So I have no
Where,
idea.
are you on web? I think you're on WebAssign. Like the actual, this is like text, I'm in the text book.
Ah. I thought you said, that's why I was looking. Okay, fine. I have both open up. Good. Got it. And we said this was
13.
a farmer wants to fence in an area, so sorry guys, I have to move you. Wants to fence an area of 1.5 square feet in a rectangular field and then divide it in half with a fence parallel to one of the sides of the. How can he do this so as to minimize the cost of the fence? Okay. Okay.
Yeah, I think by minimize the cost of the fence, they are referring to like length and width, just because the smallest length and width is going to be the most cost effective.
So I'm going to stop sharing. So coming back to what we have here is this is going to be times whatever per foot, which we don't have. So this is 3x and then plus 2 times y. So this is 3 million divided by x. So this really doesn't really matter, to be exact, right? So when I differentiate, this is a constant. So this will be whatever you want, put any price you want, and I differentiate this. So I get 3 minus 3 million divided by x squared. So the least common denominator, and I set that equal to 0. 3x squared minus 3 million must equal 0. It's over x squared. Or x squared will be 1 million. We take the square root. Okay, so what do we get? X equals plus or minus. We get 0, 0, 0. Of course, it's only 1,000 feet. So I claim that this minimizes the cost. Not good enough. I have to show this. So here's 0, here's 1,000, and here is C prime, and this is C of x, and this is 0, and we're going to find this number in a moment. But for now, I just need to find the sign of this expression. So if you plug in 0, you will get negative. If you go above 1,000, so this is typical for a minimum. If I want to find the minimum, I cannot really find it because I don't have this number. So it cannot ask us for that. It cannot ask us for this because I don't have the cost per foot. So, but it's clear that x has to be 1,000, and so this is 1,000 all the way, 1,000, 1,000, 1,000. Now I have to find y. And how do I find y? I simply put this over 1,000, so it's 1,500. So the rectangular area that encloses 1,500,000 square feet has to have a width of 1,000 and a length of 1,500. In this scenario, with 3 sides of x and 2 sides of y. So the length 1,500 and the width 1,000. It's a little bit silly because they're talking about cost, but they're not giving us the cost per foot. So you can put but I can't create this function without the cost per foot. So that's why I had to say whatever, which is okay. And then I can, when I differentiate, this is a constant, will stay outside anyway, so it doesn't affect the answer. But I can't find the cost if I don't have the cost per linear foot of fence. Okay, now I got the idea what they were asking actually.
So hypothetically,
yes.
Let's just say like the cost is $3 per foot. That would just stay a constant whenever you.
It's a constant when you it's a constant when you differentiate a constant times a function. Only the function gets differentiated.
Gotcha.
But if I have this number, then I can create this. I think I can determine this number. If you say it's $3 per foot, then I will multiply the cost with 1,000 in it by $3 a foot, and I have this number. Otherwise, they cannot ask me to find the minimum cost. If they don't give this, they can only ask find the dimensions that give the minimum cost, but they cannot ask me to find the minimum cost. Gia, is this better?
Yes.
Great.
The question, I know the question was tricky. I was like, I'm just reading off the thing.
No, but this is tricky because, see, how can I minimize a function if you don't give me everything?
This is true. I'm going to let somebody else get the floor, and I'm going to look for another question.
Do you need 14 or not?
No, but it doesn't hurt to do 14. If other people don't have any other questions, I'm going to kind of get more familiar with...
Sure, yes, let me take a look what is 14 all about. Okay, let me share my screen. Because I remember you said 13 or 14, so...
Yeah.
Okay. A farmer has 1,200 feet of fencing. Okay, which means from here till here. And according to the graph, they're telling us that this side is x and this side is 3 times as x, and obviously this one will be denoted by y. So I'm going to copy the graph and continue reading and then come back to it. So this is 14 in 4.7. Okay, so let me copy that. So I have x, I have 3x and y. Done. Fencing for enclosing a trapezoidal field, okay, along the river as shown. Thank you. One of the parallel sides is 3 times longer than the other. Fine. No fencing is near along the river. Okay. Find the largest area the farmer can enclose. Perfect. So this is a problem for the maximum area. So the area of a trapezoid is base, big base, plus small base, multiplied by the height, divided by 2. So the big base will be 3x, the small base will be x, the height will be y, so the area will be 4x times y, divided by 2, or 2xy. Again, I have to get rid of something here. And they're telling us, I forgot that piece, they're telling us that he has 1,200 feet of fencing. Fine. So that means that 1,200 equals x plus y plus 3x. X plus y plus 3x, because he said don't put a fence along the river. So this is 4x plus y equals 1,200. From here, I solve for y as negative 4x plus 1,200. This will replace this. And I found my function. So the function now is indeed a function of x, and I multiply by 2x. So I get negative 8x squared and plus 2,400x. This is quadratic. I don't even need calculus. But let's continue. A prime of x, negative 16x plus 2,400. A prime of x is 0, means x equals 2,400 divided by 16. So by 8, so 300, and I have 150. And this is in feet. So I claim that 150 for x, and 4 times 150, I think it's 600, so this is 600. Am I correct? 300, 600, yeah, okay. So I have to show y. So this is 150, a prime of x, and a of x, and this is 0. I have to study the sign. It's linear. It has a negative slope. It comes from positive and goes to negative. So this is typical for a maximum. So this is the maximum area. We have to tell him, sir, for the maximum area, make sure that this piece is 150. This piece is 3 times 150, which is 450. And this piece is 600. And here is your 1,200 feet. So if they want us to find the maximum area, then here we have to replace x by 150. So negative 8 times 150 squared plus 2400, oops, times 150, and I got the maximum area, 180,000 square feet. Very good problems.
Professor, I have a question.
Anything?
Go back.
Yes.
Can we go to the top of this one? So you said A equals 4x times y. Where did you get that 4x from?
X plus 3x. The big base is 3x, the small base is x, 3x plus x, 4x, times the height, which is y. And then I simplified here to get 2xy. And then I use the fact that he has, this is a constraint, that's all he has. So with the 1,200 feet of fencing that he has, x plus y plus 3x, this is a constraint, and he can only get a maximum area of 180,000 square feet. Now, if he changes this, of course the maximum area will change.
Thank you.
Thank you.